For years, Bihar's 100 million people have shaped the destiny of India. The time has come for its people to forge their own destiny and make the crossover to prosperity. Today, Bihar gets ready to rise and contribute to India's growth story. But for any change to happen, you need a vision fueled by an ambition. Because everything happens twice, first in the mind and then in the world outside. The river Ganga, ancient, revered and sacred. Originating from Himalayas, it reaches the plains, flowing merrily as it meanders its way through the Gangetic plains. By the time it reaches Bihar, the Ganges basin has extended to about 700,000 square kilometers, and the river becomes a white giant that separates the state in two. With passage of time, this divide has led to an unequal distribution of resources and opportunities in the state of Bihar. For economic potential to be tapped to the fullest, the need to bridge this divide has become critical.
देखो, गंगा के कारण बिहार दो भाग में बटा हुआ है, नॉर्थ बिहार और साउथ बिहार में, और दोनों रीजन का अपना अपना स्पेशलिटी है। नॉर्थ बिहार बहुत फर्टाइल है, फूड ग्रेन्स, फूड प्रोसेसिंग इंडस्ट्री सब नॉर्थ में ज़्यादा है। साउथ में हमारा पास थोड़ा मिनरल है और थोड़ा टूरिस्ट प्लेसेस हैं, बिहार का कैपिटल है। बट नाउ व्हाट वी आर फाइंडिंग, फॉर इकोनॉमिक डेवलपमेंट कनेक्टिविटी जब तक नहीं होगा, जो रिसोर्स कहीं है उसकी प्रोसेसिंग कहीं होनी है, मार्केटिंग कहीं होना है, ये सारा चीज़ जब तक इंटरलिंक प्रॉपरली नहीं होगा, एफिशिएंटली नहीं होगा, तब तक जो इकोनॉमिक डेवलपमेंट होना चाहिए नहीं होगा। जैसे अभी हमारे यहाँ प्रॉब्लम क्या हो रही है, गांधी सेतु का चूँकि लाइफ जितना था वो वहाँ बहुत सारा प्रॉब्लम हम लोग को आ गया रिपेयर मेंटेनेंस के कारण, तो हम लोगों को रेस्ट्रिक्ट कर देना पड़ा है उस पर वेहिकुलर मूवमेंट को, खास करके गुड्स के मूवमेंट को। उसके कारण पटने के मार्केट पे बहुत असर पड़ गया है। बहुत सारी चीज़ अब सीधे गांधी सेतु से नहीं आ रही है, उसको पूरा घूम के आना पड़ रहा है।
एंड कनेक्टिविटी फ्रॉम गुवाहाटी वाया बिहार वाया उत्तर प्रदेश राइट अप टू राजस्थान existed through a meter gauge network. With the adoption of Project Unigauge in 1991, we have converted most of the tracks into broad gauge. To get the full benefit of Project Unigauge, it is necessary that we connect the north bank and south bank of River Ganga in the state of Bihar more and more. At present, there is only one bridge. This is going to be the second bridge.
रेलवे का मुकामा के पास एक बहुत पुराना ब्रिज है। आज वही कनेक्टिविटी है नॉर्थ और साउथ बिहार की और एनएफ रेलवे जाने के लिए भी। ट्रैफिक बढ़ने के कारण बहुत दिन से ये नीड फील किया रही थी कि एक दूसरा पुल बनना चाहिए।
Erection was associated with this bridge in June 2008 when Ministry of Railway awarded this work to Erection, and since then there have been various developments over a time span of about 7 years, and now we are seeing the end of the work and commissioning of the railway line which is going to link the southern part of Bihar across the river Ganga to the northern Bihar. 36 spans of 123 meters and along with 2 shore spans of 64 meters each, and at 2200 tons of steel in each of these spans and 100,000 of rivets. This is the longest and the heaviest superstructure on Indian Railways.
The erection of superstructure started in September 2010. Floodplains were reclaimed with boulders and earth filling to construct the first anchor span. And within a span of 4.5 years, all of 36 spans of 80,000 metric tons of steel were mounted over River Ganga. This 4.56 kilometer bridge is Indian Railway's longest truss bridge. The foundation laying had already begun in 2002. It was decided by the ministry to add a roadway above the railway track. By that time, the foundation and the substructure were already complete.
This is the foundation portion, which is in the shape of well, and the well is like this, in the shape of double D. We have twin circular piers of outer diameter 5.5 meter, having concrete thickness of 0.8 meter. Now the founding level is -8, so the total depth is almost 60.5 meter, which is equivalent to a 17-story building.
To optimize the steel work, we had to go for higher grade of steel E450, so that the overall tonnage of the steel could be reduced, the dead weight of the superstructure could be reduced. But nonetheless, we had to use members as thick as 62 millimeters.
Fabrication with 2.5-inch steel plate was itself a task. Special radial drills and guide jigs become essential when numerous identical drill holes are needed in large numbers. The drill needs to be precise and absolutely correct in position. Once drilled, these plates will become part of a bigger steel component of the bridge superstructure. Then, these plates are welded to form a member of the steel truss. A special welding technique, submerged arc welding, is being implemented. It involves formation of an arc between continuously fed bare wire electrode and the workpiece. The process uses a flux to generate protective gases and to add alloying elements to the weld pool. When molten, the flux becomes conductive and provides a current path between the electrode and the workpiece. The molten weld and the arc zone are submerged under a granular fusible flux consisting of lime, silica, manganese oxide, calcium fluoride, and other compounds. This prevents any atmospheric contamination. Since the operator cannot observe the weld pool, great reliance must be placed on parameter setting and positioning of the filler wire. As the arc is completely covered by the flux layer, heat loss is low. There is no visible arc light, the welding is spatter-free, and there is no need for fume extraction. Once the steel is welded, it is thoroughly checked for perfection by dye-penetrating testing. Here the white color shows the weld is seamless. The prefabricated steel components are then sandblasted and metallized. Sandblasting involves propelling very fine bits of sand at high velocity to clean the steel surface. Once sandblasted, the steel is metallized with a coat of aluminium. This will provide environment and corrosion protection to the steel for decades. The steel truss cantilever bridge was a major engineering breakthrough when first put into practice. It can span distances over 460 meters and can be more efficiently constructed at difficult locations by virtue of using little or no structural reinforcements. The construction begins with one span on ground. This serves as the anchor span for cantilever cranes mounted on top of the steel superstructure. Supported by a link member which holds the free end, these cranes build the next span member by member launching ahead without any other propping from the ground. The cranes move on top, along the truss structure, adding one member at a time, forming an entire span from the free end, and land on the next pier. Before cantilever launching of a new span, the bottom chord of the new span is blocked for any backward horizontal movement. It is done by inserting a buffer block between the bottom chord of the anchor span and the bottom chord of the new span. The vertical movement of the buffer block is monitored to assess the vertical deflection caused at the far end of the new span being launched. For cantilever launching, the fabricated members were lifted to the rail level by ground cranes, then transported on temporary tracks. At the launch end, these members were lifted by cantilever cranes and fixed with drifts and bolts. On one single span of the superstructure, there are over 100,000 rivets.
इतना बड़ा रिवेट आई थिंक इंडिया के किसी ब्रिज में यूज़ नहीं हुआ है। ये इसको गर्म करना, गर्म करके फिर उतने दूरी तक ले जाना, फिर इसको ड्राइव करके हैमर करना, ये बहुत फास्ट होना चाहिए।
A rivet is a permanent mechanical fastener. It is a smooth cylindrical iron shaft with a head on one end. The end opposite to the head is called the tail. It is heated and immediately placed in a drilled hole. And the red-hot tail is then pounded to form a new head. In other words, pounding creates a new head on the other end, resulting in a rivet that once cooled has fixed itself permanently on both ends. These rivets hold the steel components fastened together permanently. In order to accomplish the task more efficiently, the engineers started construction from both sides and had plans to open a third front. But the forces of nature had something else in store for them.
This island, before 2013 floods, protruded beyond this 11th span of the bridge, up to say 100 meter on the downstream side. And suddenly, in the floods of 2013, this got washed out. It was a very big challenge for us. Then how to continue with our ambitious plan of a third front? And then we thought of a bigger barge. We brought a big barge of 1200 metric ton capacity, which carried material from the shore on the north end to the place of erection, and the entire material was lifted from the cantilever crane right from the barge, and erection was continued.
एक ट्रस का वेट 2240 मेट्रिक टन है। जब हम लोग कैंटिलीवर मेथड से इसको इरेक्ट करते हैं और दूसरे पियर पर लैंडिंग होता है तो सेंटर लाइन मैच नहीं करता है।
And if the alignment of the truss does not match the central alignment of the bridge, the entire 2,240 metric ton truss will have to be shifted into alignment.
उस केस में हम लोग ट्रैवर्सिंग जैक का इस्तेमाल करते हैं, टोटल लोड को ऊपर उठा करके और लॉन्गिट्यूडनल एंड लैटरल मूवमेंट करा के सेंट्रल लाइन को मैच कराते हैं। जो जैक इसके लिए आवश्यक था वो मार्केट में उपलब्ध नहीं था, तो हम लोग ओरियन कंपनी को बुला करके इस जैक को बनाने के लिए बोला, जो सक्सेसफुली काम किया, और आज जैक जो उपलब्ध है स्पेशली इसी प्रोजेक्ट के लिए बनाई गई है।
To build a road deck on the second level of the steel structure, the engineers had an unprecedented challenge. The concrete casting could have been done by providing traditional support reinforcements from the rail level below. But the engineers had to find a way that would not hinder the railway work and accomplish both tasks simultaneously without affecting the other.
Generally, we use props from ground, and using props from ground would have hindered the work. So we devised a method which does not use the support system. As you can see here, there is a gantry, and behind me again there is a system which is independent of support from ground.
So they developed a gantry that runs on the rails and holds aloft a large steel shutter that provides the support needed for the road construction above. On the deck, the shutter is fixed and team is welding shear studs into the steel structure. These shear studs prevent the slip between concrete and steel structure and help achieve a much stronger bond. Shear studs transfer and balance the stress between steel and concrete in a composite structure. Stud location and straightness of alignment of row over the steel cross girder and road stringers is marked with precision and care. Surface around welding location is cleaned by buffing wheel and made free from rust, dust and paint. The stud welding gun uses a type of flux called ferrule, a ceramic ring, which concentrates the heat, prevents oxidation and retains the molten metal in the weld zone. The ring is then broken and removed. An expansion joint is an assembly designed to safely absorb the heat-induced expansion and contraction of construction materials. It absorbs vibrations, it holds parts together and allows movement due to down settlement or earthquakes. This joint greatly reduces the stress that would otherwise be caused to the main structure.
ये जो है 120 mm तक एक्सपैंड कर सकता है एंड ये अपने पोजीशन में आ गया है. अब इसको फिक्स किया जाएगा थ्रू कंक्रीटिंग. ये जो एक्सपेंशन है, इस एक्सपेंशन गैप में यू कैन सी रबर हैज बीन प्रोवाइडेड हियर. तो जनरली क्या होता है, जब एक्सपेंशन जॉइंट लगते हैं तो पार्टिकल्स नीचे फॉल करते हैं एंड दे डैमेज द स्ट्रक्चर बिलो. सो यहाँ पे वो रबर दिया हुआ है सो दैट कोई भी मटेरियल ऊपर से नीचे नहीं जाए, नॉट इवन वाटर.
The first anchor span was erected on trestles in September 2010, initiating Cantilever Erection from the southern end. While on the north side, the erection began in January 2011. Taking advantage of the dry weather, additional anchor spans were built wherever there was ground support. Even midstream, the span number 27 had a patch of land underneath, adding a third front for the cantilever erection. But in 2013 floods, the land got washed away, so a floating barge was used to feed the material for midstream cantilever erection. This expedited the progress, and within 4.5 years, the erection of superstructure was complete. On 2nd of January 2015, when a bottom chord member was placed to bridge the last gap, the link between north and south was finally established.
Such kind of structures are not built daily or annually or every decade. Such kind of bridge may be a once in a lifetime construction, and I am fortunate that I have been associated with this bridge. Not many engineers will get a chance to be associated with such kind of a mega bridge construction?
From technical point of view also, it is a feather in the cap of Indian Railways. It is the longest rail-cum-road bridge in the country at 4.5 kilometer. Most of the fabrication is welded, and there is as much as 200 kilometer of welding which has been done for the bridge, and at joints we have provided rivets totaling almost 4 million. So these are all big achievements.
ये पुल बनने के बाद नॉर्थ बिहार के जितने शहर हैं वो सब पटना से बहुत नज़दीक हो जाएंगे। उदाहरण के तौर पर मुजफ्फरपुर, जो नॉर्थ बिहार का सबसे बड़ा शहर माना जाता है, उसकी अभी दूरी रेल के द्वारा 215 किलोमीटर है, और ये पुल बनने के बाद 85 किलोमीटर दूरी हो जाएगी। तो इससे लगभग 130 किलोमीटर की दूरी कम होगी। इस ब्रिज की कनेक्टिविटी रेलवे ने बहुत ही अच्छी प्लान की है। साउथ एंड पे भी वाई कनेक्शन है और नॉर्थ एंड पे भी वाई कनेक्शन है। साउथ एंड पे फुलवारी शरीफ और दानापुर दोनों से लाइन निकलकर पाटलिपुत्र स्टेशन जाती हैं, और पाटलिपुत्र से रिवर क्रॉस करके फ्री स्टेशन दिया गया है, और फिर नॉर्थ साइड में 2 स्टेशन पर कनेक्टिविटी दी है, सोनपुर में और परमानंदपुर में। इससे ट्रेन की आवाजाही में बहुत सुविधा होगी।
तो ये मानिए कि प्रदेश की राजधानी से पूरे एक गंगा उस पार के इलाके का शीघ्रातिशीघ्र संपर्क हो जाएगा, और निश्चित रूप से इससे संख्या में वृद्धि होगी यात्रियों के, और माल भाड़े में भी वृद्धि होगी, जो रेलवे का एक आर्थिक फायदा मैं कह सकता हूँ होगा।
8th August 2015, the air resounds with victorious and joyous cheers of people around. The engineers are ready to run their first railway engine over the bridge.
रेलवे के और इरकान के अधिकारियों ने जिस मेहनत से काम किया है, मैं मानता हूं कि यह बिहार के लिए बहुत अच्छी और बड़ी सौगात है। उत्तर बिहार और दक्षिण बिहार को जोड़ने में एक जीवन रेखा के रूप में साबित होगी। दानापुर और सोनपुर रेल मंडलों को जहां यह जोड़ेगी, वहीं राष्ट्रीय राजमार्ग 19 और राष्ट्रीय राजमार्ग 98 को भी जोड़ने का काम करेगी। इस रेल कम रोड ब्रिज बनने के बाद सुगमता से लोग चंपारण भी जाएंगे, और पर्यटन को भी भारी मात्रा में बढ़ावा मिलेगा। बिहार के किसानों के जो उत्पाद हैं वो भी मैं समझता हूं कि सुगमतापूर्वक बाजार तक पहुंच सकेंगे। सोनपुर से लेकर मुजफ्फरपुर, दरभंगा क्षेत्र के विद्यार्थी भी अब अपने प्रदेश की राजधानी में आकर के शिक्षा ग्रहण कर सकेंगे, रोजगार के अवसर भी उनके लिए उपलब्ध होंगे। तो ये रेलवे और इरकान ने एक बड़ी परियोजना को मूर्त रूप दिया है। मैं रेलवे को और इरकान को, उन अधिकारियों को विशेष रूप से जो इस परियोजना से जुड़े हैं, उनको बधाई देता हूं, और बिहार की जनता को यह पुल समर्पित हुआ, इसके लिए बिहार के लोगों को भी बधाई देता हूं।
Connectivity is the key to economic prosperity. When human resource is mobilized, unprecedented growth can be actualized. Job opportunities, agricultural exchange, tourism, increased productivity and efficiency are some of the immediate gains the bridge will deliver. However, homogeneous growth, decongestion of urban areas, and increased participation of villages to Bihar's economic growth will be the key long-term impact of this initiative. Bihar stands on a threshold of a dynamic phase for growth and development. This bridge over Ganges, connecting Patna with Sonepur, will be a turning point for Bihar.